We have already written code which is responsible for storing the weather location inside the local database. Our user interface is also prepared to use location. What we haven't yet implemented properly is the location provider, because at the moment it has only dummy functions which return some constant values, as you can see on the screen right now. And in this tutorial you are going to learn how to work with the location of the device and also how to fall back to the user-defined so-called custom location if the user doesn't want to grant us the location permission, which can certainly happen. Hello, welcome to Coders. So by the end of this tutorial we will have created something which looks like this. We have San Diego over here, and when we go to settings we can see that we are not using the device location, and surely the location, the custom one, is set to be San Diego. When we enable device location and go back to, for example, today, we can see that now we are inside Mountain View, and 7 days is Santiago Villa Mobile Home for some reason. And now we are Santiago Villa Mobile Home Park. This is happening because there are some problems with the emulator, because obviously I am not located in Mountain View nor in Santiago Villa Mobile Home Park, but I am located in Slovakia. But this emulator has its own kind of simulated location, and it actually changed right now from Mountain View to this Villa Mobile Home Park. So when we test it again, now we are again in San Diego, even for 7 days forecast. And now we are again in the mobile home park, which is the simulated location of our emulator. So without further ado, let's get right to it. The first thing that you may notice is that the font size is a bit smaller compared to my previous tutorial. That's because I bumped it down by 4 pixels, so it's not 26, but it's 22, and the reason for that is that you can properly see everything which is on the screen, because when it was at 26 and not 22, the text was just too large for everything to fit on the screen properly. So with that out of the way, let's implement our location provider. What we want to do first here is to have a way to fetch preferences, just like we can fetch preferences inside our data provider and then unit provider implementation. So we can basically copy all of this, but you know that when you are copying something into 2 places like we want to do now, that means that you can actually refactor that code into a separate class. So we are going to not copy it, but we are going to right now create a new class. That will be located under provider package, and then preference provider will be the class's name. As always, you can get the code from the link in the video description so that you don't have to type this all out yourself and watch me type it, which is kind of boring. But anyway, we have an abstract class, preference provider, because it's abstract so that we cannot instantiate it by itself. So it needs to be a superclass of something else in order for it to have effect, some kind of an effect. And it accepts a context, and from that context, which we pass over to preference provider, we get the application context, and then we have preferences, which is just like we have it in unit provider implementation. Basically, this is the same code as is here. So now we can delete this code from unit provider IMPL, and instead we can make this unit provider IMPL to inherit from preference provider. And actually, by convention, it's actually a good idea to put the class before the interface which is implemented. And this preference provider will be passed the context. And that's about it for the unit provider implementation. Now what we can do is to go to our location provider implementation. And over there, we also want to have a constructor which will accept a context. And similarly, it's going to inherit from preference provider, and we are gonna pass in the context in there. So this way we can get the preferences from the superclass by simply calling preferences, which calls preference manager get default shared preferences for the app context. Now what we want to do here is to do a little bit of setup for the preferences. because we have two kind of preferences for the location: use device location and also custom location. And I've just noticed that I had the taskbar still over here, so I've hidden it right now so you can see more of the screen properly without the taskbar interfering. With that out of the way, we want to go to our res, then XML, and preferences, where our preferences are defined. And we can see that the two preferences for location are over here, and we can see their keys. So the first key is use device location. We are gonna need that inside our LocationProvider implementation. So just copy that, go over here, and above the class, we are gonna create two constant vals, one for use device location and another one for custom location. We are gonna use those to get the preferences by their keys. Alright, now inside has location changed, we want to return if the device location changed or if the custom set location from the preferences changed. So first we need to define when it is that the device location changed. For that we are going to create an immutable variable, device location changed, and we need to set it to something. So we are going to get its value from a method, from a function actually, has device location changed, and we are going to pass in the last WeatherLocation. And while we are creating code which is not yet implemented, we are going to also create the return statement properly, so it's not going to just return true always, but it's going to return device location changed, which will be a boolean at some point in this tutorial, or has custom location changed, which will be also passed last WeatherLocation. So if any of these is true, it's going to return true. Now let's first create the has device location changed function, and as always you can get the code from the link in the video description. I'm going to walk you through it properly, obviously. First, there are some functions which are still not yet implemented, but they are kind of self-explanatory because that's how you should code. Your function names should reflect what the function is doing, and as you read the code, you should have a clear idea of what that code is like doing, right? So first, if we are not using device location, we want to return false because device location could not change if we are not using it. For example, if the user didn't grant us the location permission. That makes sense, right? Then, if we are using location of the device, because the user is okay with that, we want to get the device location. And we are going to get it from a function which we are going to implement in just a bit, which will get us the last device location, which is remembered. This will be handled by our library, but we will get to that later. Just for now, know that we get the device location from the last remembered device location, and we also need to await it because it's async function. And otherwise, if this getLastDeviceLocation function returns a null value, so we don't have any last location remembered, so it's null. This is the null coalescing operator, sort of. And if it's null, we are going to simply return false, because the device location did not change if there is no remembered last device location, which also still makes sense. And here we are doing a comparison of the location if we get the location properly, and we cannot just compare with two equal signs, which is the usual comparison operator, but we need to do it with a comparison threshold and with math absolute value functions, where we are subtracting the latitude of device location and the latitude of our last remembered weather location, which we are getting from our database. And we are doing the same with longitude. So if they are close enough, they are basically equal to each other. And if they are equal, we want to return false, and that's why we have the greater than operator sign here. So if the difference between latitudes and longitudes is greater than the comparison threshold, which is 0.03, the locations are not matching. And why we are doing this? Well, because latitude and longitude are doubles. As you can see right over here, it's a double, right? And doubles are not precise data types. For example, if you make a calculation which is like 0.99999 plus 0.99999, it's not going to be 2. But in the programming language case, it is going to be 2 because those two values, when they are added together, they will be kind of like sealed. So yeah, that's why we need to do this trickery around the comparison threshold and all of that. We can implement this is using device location function pretty simply by simply getting a value from the preferences under the key use device location. And we still need to implement this function get last device location. This one is a bit trickier, so I'm going to go through it bit by bit. So we have it over here, and it's going to return a deferred of type location, and it's going to be nullable, that location. And let's import the location type over here. And all the way at the beginning of this tutorial series, we have added all of the libraries to our build.gradle for the module app. And the library we want to use now is this WeatherLocation, which is the GMS Play Services Location version 16.0.0. This library provides us with a really handy class, and its name is LocationProvider Client. First, we need to have it available inside our LocationProvider implementation here. So we are going to organize this constructor, and above the context, we want to have a private val LocationProvider Client of type LocationProvider Client. Once we have it here, we can go to our getLastDeviceLocation function and do something with this property. So we want to get it from here and then call last location, and then we want to basically return it. But here is a problem. You can probably not see it properly on YouTube, but I can read it. We are missing permissions required by this LocationProvider Client, and that is access course location or access find location. For that, we need to go to our Android manifest, which is under manifests folder, and add this permission right over here. For us, it will be enough if we can access the course location, so this is pretty sufficient, but you can also add the find location if you are interested in that, but if you don't need to, don't add it. And now, even though we have added that permission already, we still get a red squiggly line, but now it says that this call requires permission, which may be rejected by user. And code should explicitly check to see if permission is available with check permission, or explicitly handle a potential security exception. We are going to go the first route, which is to check permission manually. So we are going to create a function hasLocationPermission. It's gonna return a boolean, and we basically get context compat, and we want to check self-permission, and we need to pass in an app context. So we need to create a property app context over here above everything else. So it's going to be private val app context of type context, which is gonna be equal to context.appLocation context. And now inside the hasLocationPermission, we are basically passing this context inside of there. And we also we want to check for the permission access course location, and we want to check if that permission is granted. So what we can do now is to wrap this return inside an if statement, if block, which will check for if hasLocationPermission, and if it has one, we want to return FuseLocation.lastLocation. Otherwise, so else, we want to throw a new exception, and that exception will be location permission not granted exception. So let's create it right now under the internal, then exceptions. So we want to add a new one here, location permission not granted exception, which will simply inherit from exception. And now we can use it inside our code. So we want to throw the location permission not granted exception, and we are good to go. Well, sort of good to go, because we still have an error here, and now it says that still this code requires us to check for permission. But hey, we are already checking for it, right? Well, yes, we are checking for it here, but the Kotlin compiler doesn't have any clue that we are doing that for some reason. And because of that, we need to suppress this warning. So just Alt-Enter, and we want to suppress this lint missing permission. But still, we have some error. So what is it now? Well, we should return the third location, as you can see here. But what we are returning now is task location. Why is that? Well, this is because the last location, if we check it out, is of type task. So we need to somehow convert the task to the third, and that is not all that hard because tasks contain listeners for success, so add on success listener, then failure listener. So we can really just add listeners and convert them through some code magic of Kotlin to convert these listeners to a deferred. We are not going to do this conversion directly inside of this class, but we are going to create a new file under internal, and its name will be task deferred. It's not gonna be a class because inside this file will be only one single function. And again, this is more on the complex side, so I will walk you through it step by step. This is gonna be a function which will have a generic parameter t, and it's going to be an extension function on a task. So task, and the t result will be of type t, which we have defined just here. And then it's going to be called as deferred, because this is the usual name for casting functions. And it's gonna return deferred t. We cannot just return something directly, we first need to create our own deferred. So val deferred is going to be equal to a completable deferred. So it's up to us to tell this completable deferred when it's completed and when it's not completed, and when it's completed exceptionally, which means that there is some kind of an error happening. And because we are extending the task class, we can access this, which will be of type task. And we want to add a success listener on this task, which will get us a result. And using this result, we want to complete our deferred, so we can write deferred.complete, which will do just what it tells us to do. So whenever a deferred completes and we are awaiting it, just like we are awaiting it here, right? This await will finish and we will get the value which is contained inside the deferred, inside the device location variable. But now let's come back to our task deferred. So we want to complete it and pass in the result. And the result is of type t. Then also we want to add on failure listener, and inside this failure listener we are going to get an exception, and with this exception we want to complete the deferred exceptionally and pass in the exception just like this. So this is also pretty self-explanatory. Async and wait propagate exceptions to their callers. So this is a really nice feature because in a normal threading situations you don't have that kind of a luxury to have exceptions propagated basically upwards to the calling code. This means that we can just wrap the code which is calling this as deferred extension function in normal try catch blocks, and we are going to get normal classic exception handling, which is really nice. And then finally we want to return what else than deferred. Alright, so it didn't even hurt and we have a complete as deferred converting function done. So now we can just jump right into our location provider and convert this last location to deferred with as deferred function. Oh, the beauty of Kotlin. So now we have this implemented. We also have the location permission check. We also have is using device location, which returns a preference from our preferences, from shared preferences. And we also have properly implemented has device location change function. But what we have not yet implemented is the check for if has location custom location changed, and the custom location is simply the location which the user sets right over here inside settings under location when he is not using device location. So in this case it's for example San Diego. So we want to check for this value also if it has changed. So that is pretty simple. We can just create a new function under the has device location changed, and it's going to be called has custom location changed. It's also going to be passed a last weather location, and simply this will check if the custom location name is not equal to the last weather location name, because last weather location, in addition to latitude and longitude, it also has name, region, time zone ID, zone daytime, local time, epoch, and all of that stuff. And here we are checking for name. But in order for this to function, we also need to get custom location name, and that is a separate function. And it's similar to isUsingDeviceLocation, because it's going to just simply return one preference, which is a string preference this time with key custom location, and the default value will be null, but we don't even need to worry about that. And also here the default value is true for isUsingDeviceLocation, because by default, even inside the preferences, we have it set to be true by default. So when the user launches the app for the first time, he's going to be asked if he wants to use the location of the device, and if he grants the permission, he's automatically using it. At this point, you may think that this public function, which is from the location provider interface, has location changed, is fully and properly implemented. But you are not entirely correct. This is because has device location changed is awaiting on get last device location. And get last device location can actually throw an error, throw an exception of type location permission not granted exception. Because of that, we want to go back up again and wrap this device location change equal call inside the try catch block. So first we want to try to get the has device location changed value, and if it throws an exception, we want to catch it, and we want to catch only exceptions of type location permission not granted exception. And when something like that happens, we want to return false from this catch block. So if there is no exception, the device location changed variable will be set to whatever this has device location changed function returns. However, if there is an exception, it's going to jump into this catch block, and this catch block will return false, so the whole device location changed immutable variable will be false. We still haven't implemented get preferred location string, so let's do that right now. If we are using device location, we are going to return the device location, but if we are not using it, so else, we want to simply return a string which is going to be interpolated, and it's going to call get custom location name. But if we are using device location, we first want to try, for the same reason as we are having the try catch block above, and we want to try to get the device location by awaiting get last device location. And if there is no last device location, so if it returns null, we want to return instead get custom location name, because it makes sense. If there is no device location remembered, we want to return whatever is the custom location, because we have no other choice. However, if the last device location is not null, we want to return device location.latitude and then comma and device location.longitude. You may remember that we are passing this preferred location string inside the forecast repository to call on the weather network data source, which in turn calls the Apixu Weather API. And the Apixu Weather API expects the location to be in a precise format, and that format is either the location name or the latitude, comma, and longitude. So that's why we are formatting it like this. And then again, we want to catch an exception of type location permission not granted exception, and inside of this catch block, we want to again return the custom location name. Alright, so now we can check if the location has changed, and we can also get the preferred location string. So we basically have all of the stuff for location done. We are using the Fuse LocationProvider client to get the last location, however, and this is a bit of a problem. This LocationProvider client is simplifying our lives quite a bit, but still it needs to have a bit of a setup done. This is because we are getting the last location. And in some instances, there can be no last location remembered. In that case, it's always going to return null because, hey, there is no last location which is remembered on the device. So our job now is to make sure that Fuse Location Provider client always has some kind of a location to return by observing location ourselves. For that, we want to go to main activity and create some kind of a way for us to periodically get the location of the device. For that, we need to get the Fuse Location Provider client even over here in main activity in addition to the location provider. And in order to do this properly, we need to do dependency injection. So let's jump right into forecast application. We are going to bind a new thing from provider, and we are gonna get it from location services dot get Fuse Location Provider client, and inside we want to pass in an instance of a context. And also this Fuse Location Provider client is needed inside our location provider implementation, and it also needs a context. So we are going to pass instance over here, actually two instances, one for context and one for this provider location provider client. Alright, now similarly as inside of our fragments, we can get the closest code in, but first we need to make this activity code in aware, and now we can get the override val code in by closest code in, and then we can get this Fuse Location Provider client by instance. And to check for the location periodically, we need to have some kind of a callback which will be called whenever the time it has come for us to check for the location. So we are going to create private val location callback, and it's going to be an object which is basically an anonymous class which will inherit, or actually implement or inherit, doesn't matter, inherit from location callback, and this location callback will implement one overridden function, so override fun on location result. And the thing is that we actually don't have anything to do inside this onLocation result callback function. We just want to have it over here so that we are getting some kind of a location. This is because the Fuse Location Provider client is caching the last locations itself. We don't need to do anything in order for that to happen. So we just want to check for the location periodically, and then the Fuse Location Provider client will take care of everything itself. This way the last location will not be null. Now inside onCreate, under everything else, we also want to request location permission because we need to request it on the first start of our app. The function for that will look something like this. So basically we are calling ActivityCompat request permissions, and we want to request permission for access course location, and this last argument over here, which is not yet implemented, which will be a constant, is a request code. As you can see over here, it's of type integer. This is pretty important because when you are requesting a permission, you are also going to get a callback basically, which will say whether or not the permission has been granted. And it makes sense, right? Because when you request for a permission, you want to know if the user granted or did not grant the permission and then do some actions accordingly. So now let's create this constant myPermissionAccessCourseLocation all the way on the top outside of the class. So it's a private const val and its value is 1. Now we are going to have the callback function on request permission result. So it will pass us the request code, which is our constant here, the permissions which were or were not granted, and the grant results. And over here we want to have this code, which will be an if statement. So we want to check if the request code is our code, which is equal to 1. And then if the grant results are not empty because they are an int array, and if the first grant result is granted, and because we have granted only or asked for only one permission, the first one is the access course location, obviously. And we want to do something like bind location manager, and the location manager will simply call our callback function. We're gonna implement it later, and else, so if it was not granted, we want to make a toast which will say, please set location manually in settings, so that the user can know that, yeah, he needs to set the location manually. Alright, and now inside the onCreate, after we have requested for location permission, we want to check if we already have it. So if has location permission. And by the way, even though we are requesting every single time that the app is launched, the request location permission will have some kind of an effect only on the first launch of the app, because the Android system knows if the user granted or did not grant the permission already. So let's implement even this has location permission function for checking. It's gonna be implemented really similarly to how we have it inside the LocationProvider implementation. So it's basically just gonna check context path, check self permission, access course location, and we wanna check if it's granted. So if it is granted, we also want to call bind location manager. Otherwise we can, but we don't have to, request location permission again, but I'm going to do that, but you don't have to do that if you don't want to. Alright, and now let's come to the core of this problem, which is the bind location manager. As always, I am going to be honest. What I am about to do here is not really required, because I am going to create a separate class which will implement a lifecycle observer and do all kinds of trickery, and you could do what I am about to do right inside this main activity directly without any kind of an overhead. But I think that knowing how to work with the lifecycle observer interface is really beneficial. And by the way, Lifecycle Observer is also part of the Android Jetpack libraries. With that said, let's create the Lifecycle Bound Location Manager under UI. So we want to create new class, Lifecycle Bound Location Manager. Now inside its constructor, we want to have three things. A lifecycle owner, which in our case will be the activity, because activities own a lifecycle, and lifecycle, if you have forgotten, is the onCreate, onResume, onPause, onDestroy, and all of that. Then we also have the fuse location provider client, because yeah, we need that in order to check for the location. And also we are going to get the location callback, which is nothing else than this location callback, which is basically not doing anything. It's only here for the reasons that I have already explained, which is basically that the library for fuse location provider client can remember the last location. Even before we have the lifecycle bound location manager implemented, we can still get to bind location manager function, and over here just instantiate this lifecycle bound location manager. And as the lifecycle owner, we are going to pass this, and then we are going to pass fuse location provider client for the client, and then location callback as location callback. And you may notice that I'm not using dependency injection over here, but it is not really required, because using dependency injection in this case is basically not possible, because we need to pass in basically an instance of our main activity, and I have no clue how you could do that through dependency injection. And also we need to pass in the location callback, which is also nested inside the main activity. So in this case, it's probably not feasible to do dependency injection over here, and it's really not even necessary, because hey, this is just some single instantiation, it's nothing crazy. So now let's go to lifecycle bound location manager, and it's going to be an implementer of lifecycle observer, and we are going to observe the lifecycle on our lifecycle owner, which is our main activity in this case. Inside the init block, we want to call lifecycle owner dot lifecycle, and on that lifecycle of our activity, we want to add an observer, and the observer is nothing else than this, and we can call this here because it implements lifecycle observer. Then we are going to have two functions: start location updates, which we'll call fuse location provider client request location updates, and we need to pass in a location request, which will basically tell this function how often it should request the location. Location request will look something like this. So it's a new instance of location request with properties interval set to 5,000 seconds, then fastest, or 5,000 milliseconds, excuse me, and then the fastest interval is a bit odd. We can set it to 5,000 also, so it's going to be every 5 seconds. You can make this even 1 hour or 2 hours, it doesn't matter. Just for testing purposes, I'm going to set it to 5,000, and which is 5 seconds. And then we have priority, and we have location request priority balance power accuracy, which means that we are not going to get the precise location, but we are going to get only coarse location, which is gotten from the cell towers and IP address and all of that. If you want to get a more accurate location, you can call priority high accuracy, but for that you need to have the fine location permission and not only coarse location permission, which we have in our case. And also we can just ignore this lint, so we are going to suppress lint missing permission, because at this point we need to have the permission in order for this code to be even executed. And then another function will be for removing the location updates. And here we also want to call the LocationProvider client, but this time we want to remove location updates. And now this is nice, but these two functions, start location updates and remove location updates, are not getting called. In order to change this, we need to annotate them with @on lifecycle event. So for example, start location updates will be on lifecycle event, and the lifecycle event is lifecycle dot event dot on resume. This means that whenever onResume function is called inside our main activity, this function start location updates will be called also. And then similarly, remove location updates will be called whenever the onPause is called on our main activity. Alright, so with that, we can now launch and build our app. So here we go. Our app is launched for the first time since the update which added the location check. So we are immediately asked if we want to grant the permission for using this device's location. We are going to say deny for now, and we get a toast, please set location manually in settings. So that is working properly. Now when I launch this app again, so I am going to close off everything, and I hope that this is the one which I am, yep. So we get asked again, and we can say allow now, and once we allow it, now it's observing for location. When we go to settings, however, we can see that we are not using device location, which is a bit of a bummer, but that is from the previous episodes, because this is the setting which I was using even before. So now when I change it to be true and come back, it's going to change from Los Angeles to San Diego Villa Mobile Home Park, and 7 days is still not implemented because yeah, that is the stuff for future tutorials. So definitely subscribe to this channel and also hit the bell button if you don't want to miss future parts of this tutorial series, in which we will implement this future list weather fragment and also the detail of the future weather. So whenever you click on a list item, it's going to take you to somewhat similar looking view as this today view, but for the future date. Also, I am gonna be doing some Flutter tutorials, so subscribe to this channel even for them, and you can look forward to them because Flutter is really amazing. Anyway, we can now check if the custom location still works. So it's back to Los Angeles, and when we change it to what happened? Wow, forecast MVVM has stopped. Why is that? Well, it's probably some kind of a bug, but it's not on my side because this is just the location. Alright, now it works. This must have been a bug on the Android side because I'm working with native preferences, right? I hope so. If it's my bug, let me know what I can do to fix it, but I don't think so. So we are going to change it to New York. Okay, and we can see that it still works, and now when we use device location, it still works, so we are just fine. Alright, so if this video helped you with implementing the getting of the device location and also falling back to the custom set user location when the device location permission is not granted, give this video a like and also share it with other developers. As I already said, if you don't want to miss future tutorials regarding this series where we are gonna be implementing the future weather fragment, for the list view, right, for the recycler view, and also if you don't want to miss any other future tutorials, which will include Flutter tutorials, definitely subscribe to this channel and also hit the bell button so that you are actually notified about my videos. If you have any questions regarding this tutorial or anything else to say, leave it in the comments. Follow me on Instagram, Facebook and Twitter. I go under the name ResoCoder throughout all of them, and see you in the next video.